This is a video showing a titration problem. Last video we had was using an acid that had one H and a base that had one OH. Well, here we have multiple H's and multiple OH's. So this could be used, this problem could be used for, as an example, as you're solving different acids, what we call mono or polyprotic acids and things with multiple hydroxides in it. So suppose I have 45 milliliters of a 2.85 molar solution of H3PO4, which is phosphoric acid, often found in different sodas. And if I want to titrate it with a solution of 1.29 molar barium hydroxide, BaOH2, how much of this do I need? So to do this, remember my big understanding is that moles at the equivalence point, so at the equivalence point, moles of H plus or acid are going to equal moles of OH minus. Okay? Even though this is not a strong acid, because this is a strong base, it's got OH minus in it, it's going to keep reacting and react until all these H3 H's are gone. And so we got to factor in that even though this H3 is not going to automatically dissociate and break apart in solution, all the OH's are going to keep reacting until all those are gone. So let's go ahead and figure out moles. Remember, moles is molarity times liters. So if I take 2.85 molar acid times my liters, 0.045 liters, that's going to give me 0.12825 moles of H3PO4. Okay, I'm just normally, if I do this in the calculator, you know, if I say 2.85 times, and I multiply that out, I'm just going to keep that number in the calculator. If I'm writing it out, you can round it, but if you have the number in there, just keep it in there. We'll round it at the very end. So I have this number here, but this, remember, I have 3 of these. So how do I relate my moles of H3PO4 to moles of H plus? Well, I'm going to do my chain here. Okay, so remember, I want to get my moles of acid to equal my moles of base. I'm going to see how they connect. And so I start with, my given is 0.12825 moles of H3PO4. And for every mole of H3PO4, I want to figure out how many H's I have. And how many H's? 3 moles of H plus. Okay. Now, what is my next connection? Well, I need to connect my H3PO4 with my base, my moles of acid and my moles of base. And for every H plus, I need one OH minus because I make water, right? So for one of these, I'm going to get one of these. And so for 1 mole of H plus is always 1 mole of OH minus. This always stays the same. It's always 1 H plus for 1 OH minus. Now comes my next step, and I got to see how it connects to BaOH2. Well, I want to get BaOH2, so I'm going to put 1 mole of BaOH2 at the top. And how many OH minuses for every BaOH2. And I see here there's actually 2 moles now. Okay, so I have 2 moles of OH minus. And because I have 2 moles of OH minus, now this step is different than the last video we had. So, so sometimes this ratio is going to change. Sometimes this ratio is going to change depending on what kind of acid this is, or what kind of base I have. And you just have to monitor that and see what you got. So here I have a 3 on top and a 2 on the bottom. I'm going to go ahead and now solve for this. So if I'm doing this calculation, I can multiply all these at the top, multiply all these at the bottom, and what it amounts to is I'm taking this number times 3, and all the rest is 1, and divide it by 2, so I just did that, and I end up with 0.1924, I'm going to round it, so it rounds up, moles of BaOH2. Okay. I'm not done yet. I have moles now. And it's asking me how many milliliters or how many liters do I need of this solution. So remember, my molarity is 1.29 molar, which is 1.29 moles of BaOH2 in 1 liter. And that's my molarity. And I have 0.1924 moles in question mark liters. Now I can solve for the liters here. So I'm setting up a proportion. We can also set this up using rearranging an equation. I can show you that in a second. But if I want to solve for this, you know, I cross multiply this and divide it by this number here. So this times this divided by 1.29, and that is, I just kept the number in the calculator. So my liters is 0.149 liters of BaOH2, or 149 milliliters of BaOH2. We could do it another way. Remember, liters equals moles over molarity, and that's going to give you the same thing. If I want the liters, I can plug in the moles here. I have my molarity, it's 1.29 molar here, and I can solve for that. But that is how you tackle a question that has either multiple H's or multiple OH's. Sometimes you have one, sometimes you have the other, sometimes you have both, and you just have to make sure you check and see what your ratios are here.